This is problem 8-25 from section 8.1.1. It's called the County Fair Ferris Wheel. So basically this problem is very similar to the Screamer, but instead of having a 100-foot radius, this one has a 30-foot radius. So right here is 30 feet. Okay, so that's going to be important to figuring out this table. So what they want us to do in this table is we have the angles, and so this angle right here is negative 90 degrees. Negative just means you're kind of going down first in the Screamer or on the circle rather than going up first. Okay, so I want to find the height, which the height goes along with the sine of the angle. So if you look at this and say, okay, what if I just take the sine of negative 90 degrees, which is my height, typically that's going to be -1, right? But I'm going to multiply this by the radius. Okay, so the radius is 30, so -1 times 30 gives me -30 feet. That's why they have this -30 right here. So that's what we're going to do for the rest of these. Sine, oh boy, of -45, and then multiply that by 30 since that's my radius. So I'm going to get about -21.2 feet. I'm not sure I can write that in here. Kind of. Okay, so -21.2 feet. How about think about the sine of 0, which is right here. Okay, if I have sine of 0, which is my height from the ground, which normally we assumed is right here. So the height from there would be 0 times 30 feet. Still doesn't make a difference. So my height right there would be 0. They're asking from, let's see, where is it? From above or below the central hub. So again, we're still talking about from that middle point. And this is going to be a repeated pattern here. This is going to be positive, you're above ground. If I'm at 135, that just means right here it's still the same height as if I was at 45. I'm just on the other side. Okay, so I'm going to have 21.2 here. And then I'm going to have 0. Right, I'm right over here now. This just is kind of getting you to the end. And then lastly, it'll be a -30. Okay, that gets me back where I started. Positive 270 degrees is all the way down here, which is the same thing as -90. This is the same angle, so these first ones should be exactly the same. Part A, now we have our table filled out, says the wheel goes around counterclockwise, which is the normal direction, this way, several times during a ride. How could you reflect this fact in your graph? Update your graph. So if it's going around several times, basically you're repeating this table, which would kind of be why this is happening. And we're going to repeat our graph. So if I draw a graph here, I'm just going to have it happening several times. So let's see, at -90 and -45, so I guess I should continue this over here. Let's call this -90, -45, that's 0, this is 45, 90, 135, blah blah, 270. I got some more stuff going on over here. Okay, so I am at -30, so that was, let's say down here, -21 point something, then I'm here, then I'm at positive 20 something, positive 30, positive 20 something, I'm back at a 0 somewhere, here's some space happening, and then I'm going to be back down here where -90 was. Okay, so if I update this on my graph, basically it's going to keep going. Okay, it's going to follow the same pattern, and we need to make an equation for this in part C. So I guess I won't give that away yet, but it's going to be a curve function that repeats. Okay, it's going to follow the same cycle every time. Part B, what is the maximum distance above or below the center that the top of your seat attains during the ride? So the maximum distance above or below center. Well, we can see from our table the highest value, positive or negative, is going to be 30 feet. Okay? Because the farthest I can go from the center is the actual distance of the radius. It wouldn't make sense to go longer than the radius, that means you're, I don't really know, you're not on the ride anymore. That means your C broke off, and that is bad. Part C says find an equation to fit the county fair Ferris wheel ride. So if we look at our graph here, and we could also look at our table, this point is very important, and the upward direction of this is very important. Okay, so normally the value that starts, the graph that starts at 0, 0 and goes up is sine of x. Okay, now what we changed here, the only thing that's different from normal sine of x is instead of having a radius of 1, we have a radius of 30. So what did we do to our table to find our table? Well, we multiplied it by the radius, or that would be my amplitude. Right? The distance between this maximum and the middle is 30. The minimum in the middle, also called the midline, is also 30. So my amplitude goes in front, so I'm going to have y equals 30 times sine of x will be my equation for this Ferris wheel ride. Okay, so my radius is 30, that's what makes it be different numbers than just the normal sine of the angles here. So fill out your table, make sure you draw a graph. The amplitude is 30 feet, and I use that to write my equation. Y equals 30 times sine of x.